Whoa, try that again. Hey, welcome. We are going to do a free response question this is actually the 2009 AP Computer Science A free response question. We're going to do question number one, which is that category of methods and control structures. And so obviously this one, when you'll see second, it also gets into arrays. So it does actually cover part of what might be in one of the other free response questions later. I think it's question 3 that is on arrays. But we're going to run through this. If you're watching this, it's either because you're reviewing for the AP test or it's because you're in my class and we had to cancel school for a little while and you're watching this video. So I hope this helps. But here's our situation. A statistician who studies sequences of numbers obtained by repeatedly tossing a cube, a die, as it were. On each side, there's a single number. This is just a standard die. No more numbers repeated. The statistician is particularly interested in runs of numbers. A run occurs when two or more consecutive numbers, when two or more consecutive tosses of the cube produce the same value. So, like, you're rolling dice and you get 2 5s in a row, like happened at 1, 2 here, or you get a whole bunch of 2s in a row. Anyway, for example, here's a run, and it's, there's a run starting at 1, a run starting at 6, a run starting at 12, and a run starting at 14. There is a class called NumberCube, and it has a method called toss, which tosses, and all it does is return. I mean, you could probably guess what this has in it. Math.random, and a times 6 and blah, 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 blah. It returns some integer for us, but we don't actually have to do that, so I'm not going to waste my time on it. You will implement a method that collects the results of several tosses of a cube and another method that calculates the longest run found in a sequence of tosses. So, step 1, part A, we have to get cube tosses. So basically create that array of cube tosses. And yeah, returns array when we do a bunch of tosses in a row. The parameters that we get are going to be a cube, a die. They probably used cube because die is weird to say. Anyway, and a number of tosses to be recorded, which is an integer. And there is a precondition. You can't have 0 tosses because that would cause a problem. So that's our precondition, and we return an array of number of tosses. So let's go. Let's do A. Let's put on a piece of long paper, letter size. All right. Part A. This part was given to us. We are doing a method, public method. It's a static method. It returns an integer array. And it's called get cube. What is it? Get cube tosses. Is that right? Jump back there, get cube tosses, and we get a cube and a number of tosses. So the parameters are a number cube, called cube, and an int number of tosses. Boy, I'm running out of space here. This was a long signature. All right, there we go. One of the things that I always like to do first is, I know that I need to return an integer array. So I should probably create an integer array that I'm eventually going to return. We can call it whatever we want. I often am boring and just call it result because that's what I'm return at the end, and I might even be tempted to, at the bottom of mine, write in the return result, because hey, at least then I know I have an integer array that is getting returned, and this method's going to work. But to save space, I'm going to do it like this. So anyway, integer array result, and we do need to initialize it. So it's a new array. Maybe I should say instantiate it. And to create an integer array, or to instantiate it, we need a number, or we can tell how many spots are in the array. Remember, this is an array, not an array list. An array list, we can add things to it, but in Java, an array is a set size, and we can't add or remove elements from the array. You can do that in other languages, but we're in Java. So to declare it, we'd have to give it a number, like X or 10. In this case, the number of things in our array should be the number of tosses. Cool. Now what we need to do is we've basically got an empty array with a whole bunch of null values, a whole bunch of all the values in my integer array, and my result array is just 0. So what I need to do is create one for each, get a result, basically roll the die. So how many times do I got to do it? I've got it for however many there are in number of tosses, or in my result array. So this is a typical for loop. We declare an integer I equals 0, I less than, and I typically would do this, result length. I could have used number of tosses because that is the length of result. Since I use this format all the time, I'm going to stick with what I'm familiar with. I plus. All right. Now, what I want to do is set the result. So this is iterate through every element array. So it's going to go through the 0th element, the first element, the second element, the third element, etc., through them all. And I want to set each element equal to a value. And if you remember, I'll go back here, there was this method called toss. We don't know what the implementation is, but it basically does what we need it to do. Obviously, if they give you a method, it's going to be something you're going to need to use at some point. So int equals cube dot toss. There we go. So through every element in my result array, we set it equal to some random toss, and that's about it. I can return my result now. And I'll close the bracket. Obviously, if you forget to close a bracket, it's not the end of the world. If you've tabbed it nicely and make it very clear to the grader what you're doing, you should be fine. All right, well, that was actually relatively easy. Part B is probably tougher. Obviously, if I'm making this video, I probably looked at it beforehand, so I might as well admit that. I looked at it, and I also looked at the answers, and the way it was a little bit different than the way the canonical solution was. I think theirs was actually a little more efficient, but mine felt easier to understand. So at least it was easier to me to understand because I created it this way. So I'm going to show you the way I solved it. But feel free to go online and look at the canonical solution as well. So here we go. We have to write a method, get longest run, that takes in, this whole list of values. And then it returns the starting index in the array of a run of maximum size. A run is defined as repeated occurrence of the same value in 2 or more consecutive positions, blah, 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 obviously. For example, there's a run here that starts at 1. There's another run here that starts at 6. There's a run here that starts at 12. There's another run here that starts at 14. And the longest run is, there's two of them, both 4, and they start at 6 and 14. Have I cluttered this page up enough? All right, there we go. If there are no runs, it should return a value of -1. And the other thing to highlight in here, the method may return either one of these starting indexes, so either 6 or 14. So a little flexibility there. Basically is going to tell us that if we have a less than or equals to, or just have a greater than or equals to or greater than, it's going to work. Anyway, here's my my method, public static int get longest run. So let's start there. Again, we've got a public, I'm just copying what I had in the other page. Public static int, this is going to be the index of where the longest run starts. Get longest run, and we get an integer array of values. Perfect. Like I said, I often like to just, what am I going to return in the end? In this case, I'm going to return an integer. Rather than call it result this time, I'm going to call it index, because what I'm returning is the index of where I can find the start of the longest run. That's what this method needs to do. And I'm going to set equal to -1. The reason for that, pretty simple. I need to return a -1 if there are no runs. So let's just assume there are no runs, and then if I find a run, I'll return a different index number. The other thing that I think I'm going to need to keep track of as I'm going through my thing is, what is the longest run? Currently, I'm going to set it to 1. I could set it to 0. It depends on how you want to count, but there's always a run of 1. Every single one is a run of 1. So I think this will work just fine. And then what I'm going to do is I want to go first look at this one, and then look, does the next one match it? If not, I'm done. Move on to the next one. Does the next one match it? Yes. If so, look at the next one. Does it match? No, so I'm done. And then I'll look at the next one. And if I follow the pattern, when I get to a spot like this, I'll look at this one. Like, does the next one match? Yep. Next one match? Yep. Does the next one match? Yep. So I might be going all the way to the end, and I want to make sure I don't ever try look at this cell over here, because I'd get an out of bounds index. So those are kind of the things that I'm keeping in mind as I'm doing this. And what I'm going to do is I'm going to be like, well, 1, 2, 3, 4. Nope, that one doesn't match. So my longest run is 4. And then it doesn't matter if I go to them and say 1, 2, 3. Nope, that's no longer than my longest run. So that was kind of the way I thought through the problem. So what I'm doing, if you notice the pattern there, is I'm going through each one. Sounds like a for loop. And then I'm going to, for each one, I'm going to go for the next ones, conceivably all the way down to the, I do it this way, this will make more sense. I'm going to look at this one, then I'm going to look at the next one. And if they were all the same, I'd go all the way to the end, but I'm going to break as I find one that's different. Oh, different break. So it looks like to me like a for loop inside of a for loop. All right. For int I equals 0, I less than values dot length, and I'm actually going to do -1. The reason is I don't really need to check this one to see if the next one is matching. In fact, I don't want to, because I don't want to get an error. So the last one I'm going to do here is check this one and then check to see if this one matches. All right, so values less than 1, I plus plus.